Okay, 10.2, separated by skew. It rhymed, wow. Use technology to create a dot plot that represents the distribution of the data, then describe the shape of the distribution. So you actually can't really do this on a graphing calculator. There's a way, but it's like sort of sloppy, and I don't think it's gonna make too much sense. So like, why would I teach that? So I'm just gonna do it by hand. Really, you should use graph paper, but you can these graphs are not super important for graph paper. So going from 6 to 14. So let's use centimeters, and let's do every half inch. And so I'm starting at 0, half centimeter. So that's 7, 8, 9, 10, 11, 12, 13, 14. Oh, that was it. Okay. So we get 6, 7, 8, 10, 11, 12, 13, 14. Great. Let's see, 6 once, 7 once, 8 twice, 9 3 times. I notice I'm trying to keep them all parallel, the dots. I want them to be aligned. 10 has 4, 11 has 3, 12 has 2, 13 has 1, and 14 has 1. Okay, so think about the words we talked about in Monday's lesson. There were 4 words that we really used to describe a distribution, distributions in general. What are the words you would use to describe this one? All right, so there are 2 words that came to my mind. One being symmetrical. All right, I can put a line right down the middle and it cuts it in half perfectly. All right, then we've got a symmetric distribution. Symmetric distribution. Another word we used was a bell-shaped curve, or more informally known as like a bell curve. All right, and it's, of course, these are all words that refer to distribution. Symmetrical distribution, bell-shaped curve distribution, bell curve distribution. You can just say bell curve. Bell-shaped, I don't think is really necessary. Bell curve, that's short enough. That's good. This is what it means. All right, and we see, it sort of follows this sort of curve. It looks like a bell jar. When people say like a bell jar, like I don't know if you've ever seen like the Hunchback of Notre Dame where like they're ringing a bell. That's what they're talking about. All right, so find the mean and median of the data. So, one way we find the mean, all right, add numbers up, and then we divide by number of numbers. Let me write that clearly. I don't think you can read that. Add all numbers in set, and then median just equals the middle. But we are above that now. We have technology, sorry if that was loud, that can do all the work for us. Can we see that? There, that looks like a better angle. Let me get the dust off the screen. All right, so if you remember, we go to stat, then we go to edit, and then we're gonna, good. So then we're gonna go to stat, calc, and then we'll go to 1-bar stats. I'll show that again. Stat, press right over to calc, enter on 1-bar stats, 1 variable statistics, and it did it twice in a row, so I have to delete one of them. All right, and we want to do it for L1, so I'm pressing second 1 for L1. All right, so remember X bar is a much fancier way of saying the mean. So we say X bar is equal to 10. The median, the middle, they call it med in here, is equal to 10. I want to show you something else that's kind of cool about this. Maybe you'll think it's cool, maybe you won't. So when we say add all numbers up, adding up numbers is called a summation. When you add a bunch of numbers together, we call that a summation. And the symbol for that is this Greek letter, I believe it's epsilon. So if you look here on the calculator, they have this Greek letter epsilon. So they're saying the summation of all those numbers is 180. Then it says n is 18. So we've got 18 numbers in total. If we divide 180 by 18, we also get our mean of 10. That's how they're calculating it. Adding up all the numbers, dividing by the number of numbers. So I know that that's good for sure. All right. So that was much easier doing it on my calculator than actually having to do all that work. Okay. Find the mean and median of the data with 2 additional values included as described. All right. So I'm going to go ahead and write x bar equal and median. Right. That's the average, the mean. Just writing it shorthand as x bar because it's got x with a bar on top of it. I don't know if there's a shorthand for median. I should find that out, right? That's my job. I'll look it up. So I would recommend you try and do these as well, just to see how it works for you, because they just say add 2 values greater than 14. So it could be any number, really. It doesn't have to be the numbers I'm putting in. All right, so now I'm going to go to stat, edit, and I'm going to add all the way at the bottom just 2 numbers that are greater than 14. That's all they're asking me to do. So I'm going to pick, let's add 20 and 18. All right, I'm going to go back, do the same test again. Now I see my mean is 10.9. And my median is 10. So let's write the original at the top. So the original was 10 and 10. Because it's sort of hard to compare these things if we don't know what the originals were. All right, so I notice mean changed, median did not. Interesting. All right, let's go back to our list. So notice how they say the original data set, right? So that means I have to go over to 20 and 18 and delete them out of my list. So I'm just pressing this button, del, delete right there. All right, so 2 numbers that are less than 6. So let's try 1 and 3. Go run my test again. All right, we get a mean of 9.2. And we get a median of 10. So again, my mean went down, my median stayed the same. Interesting. Add 1 value that is greater than 14 and 1 that is less than 6. So quickly go back. Oops, not that. Stat, edit. And actually, one quick trick to save yourself some time. If you just go to the top of the list, it'll bring you to the bottom if you keep going up, because that is pretty annoying to have to scroll all the way down to the bottom of the list. There might be another shortcut besides the one I put. So I'm going to delete 3. I need 1 value less than 6, and I'll put 20 is my other value. So let's see how that affects it. So we get a mean of 10.05. You know what I should also write? The numbers I added. So here I added 16, 20. Here I added 1 and 3. Now I'm adding 1 and 20. All right, and it looks like the median, is still 10. Wow. So median's not changed at all. Mean changed a little bit. So I wonder why it changed a little bit up and not a little bit down. It's interesting to think about. All right, add 2 values, 50 and 100. So now I don't have a choice. Now I have to go down, delete 1 and 20, and add 50 and 100. All right, run the same test. All right, so my mean is, let's see, my mean is 16.5. Wow, I really went up. And my median is still 10. Crazy, right? Crazy. So look at all these values. We see our mean has changed a lot. Median has not changed a bit.